here we're going to practice with one more polynomial and find its real roots or real zeros using all of the tools that we've been studying. Notice that we are going to use Descartes' rule of signs, and so if you haven't watched that video, please do that and then return to this video. So here we have that p of x is equal to 6x to the fourth minus 11x cubed minus 12x squared plus 5x. And the first thing that I notice here is that x is a factor. So if I factor out the x, I get 6x cubed minus 11x squared minus 12x plus 5. And this polynomial, if we use Descartes' rule of sign on the remaining polynomial, we see that there are two changes of sign, from the first to the second term and the third to the fourth term. So looks like two positive zeros possible. If we replace the x by the opposite of x in each of these, we would get minus 6x cubed minus 11x squared plus 12x plus 5. And it looks like we've got one change of sign there, so one negative 0. Rational zero, real zero possible. So 4 real zeros altogether, because x equals 0 is going to be one of the zeros. So when we look at our rational zeros theorem, there's going to be positive and negative options here. And again, we're only looking at the trinomial. So the constant term is 5. The divisors of 5 are 1 and 5. Those are the only options for the numerator. And the options in the denominator must be divisors of the leading coefficient, which is 6. So 1, 2, 3, and 6. So our possibilities, starting with the 6, 1/6, 5/6, 1/3, 5/3, 1/2, 5/2, and 1 and 5. Both positive and negative. So let's look and see if we can make a educated guess as far as a rational zero. I've entered the function in the y equals screen. Let's just go to zoom standard, so zoom 6. And it appears as if we are going to have a positive 0 and a positive real 0 and a negative real 0. Let's focus on that negative real 0 to start with. And so the negative real 0, let's adjust our graphing calculator to a y min of -3 and a y max, or let's go -4 to 4. So -4 to 4. And it looks as if we may have a rational 0 at -1 in addition to 0. So let's see if -1 actually works when we use synthetic division. So we're going to do this on the cubic function. Six, -11, -12, and 5 are the zeros. So 6 will be the leading coefficient of the quotient. 6 times -1 is -6. Add to -11 is -17. Times -1 is 17. Add -12 is 5. Times -1 is -5. The remainder is 0. And -1 is a rational 0 this time. We now have a quotient which represents a quadratic polynomial. We can use the quadratic formula where a is 6, b is -17, and c is 5. So x would equal 17 plus or minus the square of -17, which is 289, minus 4 times 6 times 5, that's 4ac, all over 2a, which is 2 times 6, or 12. And so that's going to be 17 plus or minus the square root of 289 minus 4 times 30, which is 120, all over 12. 17 plus or minus the square root of 169, all over 12. And the square root of 169 is 13, so we get 17 plus or minus 13 over 12. That's going to give us 30 over 12, which dividing by 3, we're dividing by 6, gives us 5 halves. And 4 divided by 12th, which is 1/3. So our zeros this time the rational zeros are, and they are all rational zeros, -1, 0, 1/3, and 5/2.